Hello kids, before we continue with section 11.5 where we're doing more work with completing the square, I have two questions for you. If I can remember, the first one was, why could the hen not find her eggs? Because she had mislaid them. And I'm thinking that these hens must be related to my hens. I was out in our shop this morning and the hens had found a box of roofing nails, and roofing nails are what you use when you're putting tar paper or shingles on a roof, and the hens had crawled in there to lay yet another egg in the box of nails. Certainly not the softest place around, even though we had made them nice, soft nesting boxes. She decided to lay an egg on top of the nails. And the second question is, what kind of a mouse, well, I just told you the answer. What kind of an animal needs to be oiled? A mouse, because it squeaks. So let's go ahead and move on with section 11.5, completing the square with leading coefficients. 4x squared plus 8x minus 5 is equal to 0. 4x squared plus 8x minus 5 is equal to 0. This is example number 1 of section 11.5 in your Bob Jones University Press, Algebra 1 2nd edition book. And what you've learned so far about completing the square is that you need to have the variables on the left-hand side of the equation and your constant term on the right-hand side of the equation. Now, can we just go ahead and take half of 8 and square it and add to complete our square? Well, you might think that you can, but if you've read your book, which I hope you have by now, you've learned that to complete the square only works completing the square under a particular condition. The leading coefficient is equal to 1. So what do I mean when I say that the leading coefficient is equal to 1? Well, what that means is you have arranged your equation so that you have it set up in descending powers, descending order according to what power the variable is. Quadratic equations are second degree equations. And remember that the coefficient is the number part of that algebraic term. So we have a 4 here. Well, leading coefficient. The leading coefficient is the first coefficient in your algebraic expression, and that has to be a 1. Is it a 1? Nope, it's not a 1. So if you do not have a 1 as your leading coefficient, meaning that if you have any number showing up there at all, because when we have a leading coefficient of 1, we don't even write that down. You're going to have to factor that leading coefficient out of your entire expression. So if we factor out a 4 times what is x squared? 4 times 1, x squared. 4 times x squared, 4 times what is 8x? You have 2x is equal to 5. And now this is where you have to be very careful. First, you have to factor out so that your leading coefficient is 1. Factor so that your leading coefficient is equal to 1. That's your first step when you have an expression that you're trying to factor by completing the square, or your leading coefficient's not 1. First, you have to factor so that the leading coefficient is 1. And second, you have to complete the square inside the parentheses. inside the parentheses. What do I mean by that? Well, when you factor something out, you're sort of using the distributive property in reverse. So we have 4 times everything that's within the parentheses. So you simply look inside the parentheses, you have x squared plus 2x. Now you have an expression that you can complete the square on, because the coefficient of that first term is 1. What's half of this first term? Half of the coefficient of the first degree term is 1. Square that and add it. Now, what am I going to add to the right-hand side of the equation? Remember, when you complete a square, what you add to one side of the equation, you have to add to the other side of the equation so that your equation remains in balance. I've added a 1 here. Am I going to go ahead and add a 1 on the right-hand side? Well, you're thinking, must not be a 1 that I'm going to add. I'm not sure why, but the way Miss Betsy's asking the question, I know that 1 can't be the right answer. Well, you're correct. 1 is not the correct answer. Let's look at this. 4 times x squared gives me 4x squared. 4 times 2x gives me 8x. 4 times 1 is 4. So it looks as though I have only added 1 to the left-hand side of the equation, but I've actually added 4, because you have to take into consideration that this 4 is distributed to every term that's inside the parentheses. 4 times 1 is equal to 4, so we add a 4 to the right-hand side of the equation. Now, we can go ahead and continue with our work. We have 4 times what? Well, we have a perfect square trinomial inside the parentheses. So we factor this as a perfect square trinomial is equal to 9. Now, do I care about 4 factors of x plus 1? No. I want to have only care about one of those factors. So how do I remove this 4? Exactly. You divide both sides of the equation by 4. I now have x plus 1, quantity squared, is equal to 9/4. Take the square root of both sides of the equation, plus or minus the square root of 9/4. Let's pause here and review. When we're completing the square, your leading coefficient always has to be 1. If you have a problem that you're trying to use the method of completing the square by to come up with the conclusion, to come up with the solution, if that leading coefficient is not equal to 1, then you need to factor, first off, so that the leading coefficient becomes 1. It's exactly what we did in this step here. We factored out a 4. Which meant that within the parentheses here, we now have an expression with the leading coefficient of 1. So we can factor this. After you have factored to end up with a leading coefficient of 1, then you're going to complete the square inside the parentheses. And when you complete the square inside the parentheses, that puts a little bit of a different twist on your problem. You're not just adding that number that's within the parentheses to the left-hand side of the equation, but you're taking into consideration the fact that you have the distributive property. So you have the product of that number inside the parentheses and whatever you have factored out. So that's how, in this particular problem, we end up adding a 4 on the right-hand side of the equation because we've actually added a 4 to the left-hand side of the equation. Then we work down here to where we're going to take the square root of both sides of the equation. What we have here, we have the square root of 9/4. You're going to take the square root of a fraction. Now I can look at that and say the answer is 3/4. You can also take it as the square root of the numerator divided by the square root of the denominator to end up with the square root of 9/4 being 3/2. So our next step here says x plus 1 is equal to plus or minus 3/2. I think this is just too funny because this is a different problem that's very, very similar to the last example that I worked on section 11.4. Now, what do I have to do? Do I care about x plus 1? No, I don't care about x plus 1. Just care about an x, so I'm going to subtract a 1 from both sides of the equation. So I have -1 plus or minus 3/2. Let's come over here to finish our problem. -1 plus 3/2. That's -2/2 plus 3/2. That gives me a positive 1/2. Or I have -1 minus 3/2, which will give me a -5/2. These are the two possible solutions to this problem. You can verify that these are the correct solutions by individually plugging them into the original equation, and you'll see that it works. That was example number 1. Let's go ahead and do another problem. I'm not going to do example number 2 because I figure at this point that you can look at example number 2. We spent a lot of time going over these in class. We spent time on Tuesday going over some of these. So let's look at an example from your homework. (3x² plus 18x is equal to 2). This is number 2. Number 2. 3x² plus 18x is equal to 2. The question here is very simple. We're not asking you to solve it. They just want to know how much do you add to the right-hand side of the equation. Well, is the leading coefficient here 1? No, it's not. You got to make sure that you look for that. 3 times x² plus what? It's going to be plus 6x. This is this distributive property in reverse. Now, how do we determine what we're going to add to complete the square? You take half the coefficient of the first degree term, which is 3. You square that, and you add that to both sides of the equation. So what am I actually adding? Am I adding a 9? No, I am not. Because I have to take, because I'm completing the square with inside the parentheses, I have to take into consideration that I have this multiplier out here. The constant term that I factored out, 3 times 9 is 27. So the number that I'm adding to the right-hand side of the equation, or the total number that's being added, is actually a 27. You're writing it here as a 9, but that's because it's 3 times 9 is 27. So since you've added 27 to the left-hand side of the equation, you also have to add that to the right-hand side of the equation. That's how these work. I'm going to go ahead and do one more example for you. I'm going to go ahead and actually do one from your homework. Can you believe it? This is going to be problem number 7. And let's see what we have. 3x squared minus 12x is a minus 3. 3x squared minus 12x is a minus 3. This is problem number 7 of section 11.5 in your book. We're solving this equation by completing the square. If we complete the square, our leading coefficient, the coefficient of our squared term, has to be 1. Because it's not a 1, we're going to factor out that 3x squared minus 4x is equal to negative 3. And then we're going to go ahead and complete the square within the parentheses. We complete the square by taking half the coefficient of the first degree term, which is a negative 2, and squaring it to be 4. We've now completed the square within the parentheses. We have x squared minus 4x plus 4. But did we actually only add 4 to the left-hand side of the equation? No, we didn't. We added 3 times 4. 3 times 4 is 12. So we have to add a 12 to the right-hand side of the equation. And then we can go ahead and complete our work. We have 3 times x minus 2 squared is equal to negative 3 plus 12 is 9. Not 19, but 9. How did I get this x minus 2 here? This is a perfect square trinomial. Perfect square trinomial. The way you back to the perfect square trinomial, x minus 2 squared. We have a multiplier here of 3. We don't care about three of these factors, so we're going to divide both sides of this equation by 3, which ends up with x minus 2 quantity squared is equal to 3. We have a perfect square on the left-hand side of the equation. The way to solve this is to take the square root of both sides of the equation. When you take the square root of a constant term, it's plus or minus. So we have plus or minus the square root of 3. The square root of x minus 2 quantity squared, x minus 2 is equal to plus or minus the square root of 3. X minus 2 plus 2, we add a 2 to both sides of the equation. X is equal to 2 plus or minus the square root of 3. That's all there is to working these. And I know I keep saying that's all there is, and yes, I do have a lot more experience than you do. But if you learn the methodology for how you do these things, and if you're careful too with your algebra and careful with your radicals, you won't have any difficulty doing these, but they will take you a while to complete. Don't think that you can get your homework done in half an hour, because it's just not going to happen. They're lengthy problems to do, but you're well capable of doing them. And I'll see you next time.